Good evening. This is going to be my explanation for problems 4 and 6 on the midterm reviews. Well, first I'm going to start off with number 4. It's essentially the water cistern problem. This one's going to basically be over the fact of we need to find out what the rate of change is with respect to time, the whole entire effect of the chlorine coming in with the water coming in. So we have a cistern that has a flow rate of water coming in at 900 gallons per year, with also a rate of chlorine coming in at 0.8 milligrams per gallon of water that's coming in. From there, we have our output of 800 gallons per year. The question is really how much chlorine is basically collecting in the cistern. So the way we want to do this first is essentially build a mathematical model that represents this. And so if we have any initial conditions, any essential numbers to throw in, we can essentially find out exactly how much chlorine is essentially collecting in the cistern over the year, or over at least the period of time. So the way I started off was essentially finding my dyn, because we know that our total equation is going to come out to be dy dt is equal to our dyn minus our dy out. This total is going to give us our complete equation to put into to respect our initial conditions, whatever we may have, or any numbers we may plug in. So let's start off with I started off with my dyn, which is essentially the flow rate of the liquid multiplied by the concentration. So we're essentially looking for the volume over time with multiply that by the mass over the volume. So we may get the mass over time, which is essentially what we're looking for. We're looking for the amount of concentration, the amount of chlorine in the cistern over a period of time. Using this, our givens within the paragraph, we had a total of 900 gallons per year with a total concentration of chlorine coming in at 0.8 milligrams per gallon. This, if you do the mathematical, if you do the arithmetic, you're basically going to get 720 milligrams per year. So, okay, now we got that one out of the way. Now we got to do dy out. It's essentially our rate of change over time as the liquid is flowing out of the cistern. So we have our concentration multiplied by our flow rate of liquid out, which if we go back to our unit check, which is mass over volume multiplied by our volume over time, which will still get us the mass over time, which is basically where we're going to get to once dy dt is going to give us a mass. We can only subtract the same units using the same units, so we have to do mass over time and mass over time. All right. Now, given the information that was given to us in the paragraph, we have a flow rate out of water coming out at 800 gallons per year, multiplied by a concentration. But the interesting thing is, though, we don't know that concentration yet of chlorine, in which we're trying to find. So we can say that constant, some constant C, or at least I place C, in milligrams, divided by exactly what was that? Initially, my question was, what am I dividing by? Well, if we look at it, we have an input of 900 gallons per year, and we have an output of 800 gallons per year. So given that we have done several examples in class, I use that, and we have essentially a total difference of 100 gallons per year, not only including the fact that we already have an initial volume in the cistern of 100 gallons. So I decided to divide that by our initial condition, which was 100 gallons in the cistern of water, plus our essential difference in gallons per year, which is essentially eventually adding up over time, multiplied by our T, our time in years. And if we do a quick units check, which years, gallons, we would essentially get the same units as what we need, which is mass over time. So that's why I have over here, originally we have 900 gallons minus the 800 gallons, and our initial volume is over here. So essentially by taking all these and summing them up into one simple equation, we can essentially say dy dt is equal to dyn over dt minus dy out over dt. So what we're going to get is going to be plug and play, basically. 720 milligrams per year minus 800 C, all divided by 100 plus 100t milligrams per year. The only reason why if you may be asking why didn't I combine these two? Well, in fact is, well, you can't because this one has a t involved. And so we can see right over here that that our units are the same. So it's going to give us the exact answer we want, which is the amount of chlorine that is going to be settled into the cistern per year. Thank you for watching. The next one's coming up is going to be the, how do we call it? Number 6.